This is lesson AMU1L6, and we're going to talk about linear, literal, and absolute value equations. Let's start with linear. What is a linear equation? Well, by definition, it is an equation whose graph is a straight line. That's the basics of it. But you don't want to graph every equation to see if it's a straight line. So we start to look for commonalities. Now, it can be written as ax plus by is equal to c. That's always going to graph as a straight line. So let's look at some examples. This would be your basic one. 2x plus 3y is equal to 5. That's going to graph as a straight line. However, 2x equals 5 is also a straight line, as is 3y equals 5. But it doesn't look like this, but technically it does, because what they're saying is you could possibly write this as 2x plus 0y equals 5, then it fits your pattern, or this could have been 0x plus 3y equals 5. Once again, technically fits the pattern. So let's just look at a few non-examples, and that might help you better understand what is and is not a linear equation. Another more specific definition of a linear equation, or a way to recognize them, is each term has only one variable, and each variable has an exponent of 1. So let's look at this one. X squared, these are counter examples. X squared equals 7, that is not a linear equation. You know, that's going to be your parabola, but it does not have an exponent of 1. All right, x times y equals 3 is eliminated because the term has more than one variable. X times y, I mean, what if x is equal to y? Then you wind up with something squared, and that's going to give you a parabola. And same thing with x over y. Y actually has an exponent. And what is it? Well, it's in your denominator, so y down there is actually y to the negative 1, which is not an exponent of 1. So these are three of the main things you can look at if you're trying to eliminate something as being a linear equation. So let's just look at how to solve some now. So real quick, let's just review our rules and our steps about solving linear equations. There's only one rule, and that rule is to do the same thing to both sides. That's what keeps it balanced. But we do have some steps that are best practices. This just helps you solve an equation efficiently and not make a mess. So the steps are, first, get rid of any fractions or decimals. And you remember we do that by, well, you can multiply all the way through by the denominator, or you can multiply by tens or multiples of tens to get rid of decimals. It'll move your decimal over. So next is to simplify each side. You look at each expression in your equation, each left and right, and you do PEMDAS or GEMDAS to each side. Whatever you can do to simplify that. Then we're ready to start work. You need to get rid of all but one variable term. This is usually the step that I see people skip. They just start winging it at this point, and that's when they create a mess or they get confused. So just remember, step 3 is to if you have more than one variable in there, if you have an x over here and an x over here, you need to get rid of one of them. Number 4 is to get rid of the numbers added to or subtracted from your variable term by doing the opposite of what's been done. And number 5 is to get rid of numbers multiplied by the variable by doing the opposite of what's been done. So if you need to pause it long enough to copy these down, go ahead, but I'm going to move on into working a problem. Okay, let's look at number 1 in your guided notes. 39 minus 5k is equal to 1 minus 8 times negative 8 minus k. So there are no fractions or decimals to worry about. That was step 1. We're good to go. Step 2 tells me to simplify on each side. Now over here on this side, that's simplified. That expression is as simple as it gets. But over here, I have these parentheses, so I'm going to distribute that minus 8 into there. Now what happens when you distribute a negative number? It changes. So negative 8 times negative 8 is positive 64, and negative 8 or minus 8 times minus k is plus 8k. Now we can also add those two together, simplify a little bit more, and that's going to give us 65 plus 8k. All right, going down our steps in our head, the next thing is to get rid of all but one variable term. Well, I have a minus 5k here and a plus 8k over there. If you have the option, whether subtraction or addition, I always choose to add. So I'm going to add 5k to each side. So now I have 39 equals 65 plus 13k. Okay, and then my next step is to get rid of any numbers added to or subtracted from the variable terms. 65 is added, so I'm going to subtract 65 from each side. Now that's going to give me 13k is equal to negative 26. And then moving into my last step, get rid of the numbers multiplied by the variable. I'm going to divide both sides by 13. And k is equal to negative 2. Okay, here we are at number 2 on your guided notes. Now, this one does have a fraction, so I choose to get rid of it first. And I'm going to do that by multiplying both sides by that number. So that's going to be negative 7. Now over here, these two will cancel out, and I'm left with 4y minus 7. When I distribute negative 7 into this, negative 7 times 1 is negative 7, and negative times negative 6 is going to be positive 42y. All right, there's nothing to simplify. That was step 2. Step 3 is to get rid of all but one variable terms. Well, I have a 4y here and a 42y there. They're both added, so either way, I'm just going to subtract 1, so I'll get rid of the smaller one. So that leaves me negative 7 is equal to negative 7 plus 42 minus 4y is 38y. All right, next I want to get rid of the number added to the variable term. That's 7. So I'm going to add 7 to each side. Now I have 38y is equal to 0. 0 is a perfectly acceptable number. This is usually where people kind of panic and think they did something wrong. 0 is a number, okay? So divide both sides, just keep doing what you know to do. If your math is correct, and you should check your figures, but if it's correct, then you're going to get the right answer. So y is equal to 0. Okay, we're example 3 on your guided notes, and here's your equation. Now we do have a fraction, and our first step was to get rid of fractions or decimals. Normally, the way I get rid of a fraction is I just multiply all the way through by the denominator, and yes, it would get messy over here, but then I would be done with fractions. However, there's something very interesting that catches my eye. These two numbers are both multiples of 3. So what I can do, this says divided by 3. This is actually divide by 3. I could distribute that 3 divided by 3 into this set of parentheses and get rid of it. So if I take it here and I'm just going to divide both of these things by 3, what I'm going to have now is 3w minus 17. Okay, now let's do all the simplifying in the same step. So we've still got that just like it is. All right, next is to simplify each side. So I'm going to distribute this into here. 4 times 3w is 12w. And 4 times negative 17 is 68. Now over here, what am I going to distribute into this set of parentheses? Well, that minus sign. So I'm going to have 7w minus 68. Now when you do minus times minus, that's going to change to plus 5w. Now if you look, I can still do some simplifying here. I can combine 7w plus 5w and get 12. And then nothing has changed over here. Now my next step is to get rid of all but one variable term. When you look at this, I've got a 12 and a 12. So let's get rid of one. Both of them are positive, so I'm going to subtract. And this is usually where people start to panic again and say, oh, I must have done something wrong. Well, you didn't. You did everything to both sides, just like the steps said. So let's just go with it and see what happens. Now you have negative 68 equals negative 68. Sometimes you get an equation like this. This is a true statement. Your option at this point is it true or is it not true? Well, if it's true, then your answer is the infinite solution. All real numbers, any number. All right, any number that you put into this equation for W will work. And example number 4 on your guided notes here. Once again, we have this fraction in here, and while it's tempting just to go ahead and multiply both sides by 2, wouldn't be that big a mess, but I also see here, if I go ahead and distribute this fraction, it's going to create whole numbers. So that's what I'm going to do here. Let's look over here and see if we can kind of simplify. 3x minus x will give us 2x plus 11 here. Let's go ahead and get that out of the way. Now, when you multiply 3 halves into this set of parentheses, 3 times 4 is 12, and 2 times 3 is 6, and 12 over 6 is 2x. See what I'm saying? Now when you multiply 3 times 12, remember that's like 12 over 1. So 3 times 12 would give you 36. 2 times 1 is 2. And 36 over 2 is 18. And then we have that plus 7 to come along. Now let's also go ahead over here. 18 plus 7 is 25. So now I have 2x plus 11 equals 2x plus 25. And once again, we have two variable terms, so let's get rid of those. They're both positive, so we're just going to subtract. We're doing it to both sides. These two also will cancel out, and you're going to wind up with 11 equals 25, which is not a true statement this time. So your answer to this is the empty set, the null set. There is no solution. So however you want to write that, there is not a number that you can plug into this and make this be a true statement. Okay, let's move on to literal now. Okay, literal equations are when you have more than one variable and you are asked to solve it for a certain variable. This is more formula manipulation. When you have an equation that has more than one variable, take x plus y is equal to 5. You don't have one solution. You have a lot of solutions. But sometimes you're going to want to solve it for one of the variables. So if I want to solve this for y, that means get rid of everything attached to the y. Using all those steps that we just used, but we're not going to get an exact answer. We're just going to get the rearranged version of the formula. So let's look at the next one. Okay, number 5 tells us to solve this equation for j. So I look and I say, well, j's on the is a denominator, in the denominator. So let me get it out of the denominator first by multiplying both sides by 3j. Right, these two cancel out, so now I have 8h over here. And here I've got 6 times 3 is 18kj. Now remember, I'm solving for j. What's attached to it now? The 18 and the k are attached by multiplication. So now you divide both sides by 18k, and then let's reduce. What will go into 8 and into 18? 2. So I would have 4h over 9k equals j. Okay, let's look at number 6. A is equal to 1/2 h times b1 plus b2, and we want to solve this for b sub 1, right? Right here. It's inside those parentheses, so I'm going to have to dig for it a little bit. First, I'm going to move these two things over here. How would you do that? Well, how would you move the 1/2? Well, multiply by 2. So if I multiply both sides by 2, what I get now is 2a, and 1/2 times 2 just goes to 1. And I've got h is equal to b1 plus b2. All right, now, how is h attached to this set of parentheses? By multiplication. So now I'm going to divide both sides by h. So I have 2a over h is equal to B1 plus B2. Now, since there's nothing outside the parentheses, I can just say, well, I've distributed positive 1, so now I have B1 plus B2. And I'm solving for B1. How do I get rid of B2? Well, I'm just going to subtract it from each side. So what I have as my final answer is 2A over H minus B sub 2 is equal to B1. It's just manipulation. I haven't lost anything, I just put it in a different order. So number 7, 3x plus 4y squared equals 7z 4y. So let's identify our variable. I want to get this one. So we're just going to start getting rid of everything that is attached to that variable. Well, the first thing, the 3x way out here, if I'm going to get rid of that, I have to subtract it, and to keep it balanced, I've got to do it to both sides. So now what I have is 4y squared is equal to 7z minus 3x. All right, next, the 4 is attached, so what I'm going to do there is divide both sides by 4. So now I have y squared is equal to 7z minus 3x over 4. All right, I need y, not y squared. So how do you get rid of an exponent? Well, you take the root of it. Since it's squared, I'm going to take the square root of this side, and I'm also going to take the square root of this side. Now, since you are taking the square root, you need to put in the plus or minus sign. So now what I have is y equals, all right, this is going to be the square root of 7z minus 3x, and 4 down here is a perfect square. So if you want to at this point, let's just go ahead and take the square root of it and make it 2, and don't forget your plus or minus sign. And so that's going to be your manipulated version solved for y. Okay, number 8, mn minus p is equal to 2m, and they want us to solve for m. Now this one's pretty tricky because you have m here and m here. So the first thing I want to do in a literal equation is get all my variables that the variable that I'm solving for. If there's more than one, I want to get it on the same side of the equal sign. So I'm just going to move this by subtracting 2m from each side. So now I have mn minus 2m minus p is equal to 0. Now let me go ahead and move the p away from my m's. So now what I have is mn minus 2m is equal to p. Now you notice both of these have an m, and I want that m out of there, so I am going to take it out as a greatest common factor. In other words, I'm going to undistribute it. I'm going to pull the m out of this binomial, and that's going to leave me n minus 2. And now you can see easily I can divide both sides by n minus 2. These will cancel out, and I have m is equal to p over n minus 2. The last part of this lesson is about absolute value equations and how to solve those. So let's talk about our steps here in case you've forgotten. First is to isolate the absolute value. Now, if you have guided notes, if you look up there at the top, if yours says isolate the inequality, you need to mark through that and put absolute value. That should read isolate the absolute value. Then you're going to create two cases and then solve each case. So what does all that mean? Well, remember with absolute value, that has no sign. So if I just tell you that the absolute value of x is equal to 7, you really don't know if x started off as 7 or negative 7. So that's why we have to create two cases. It could have been positive 7 or it could have been negative 7. I really don't know. So that's why we examine both cases, test both answers. A lot of times both answers work. Sometimes only one works. Sometimes none of them do. So we always have to test our answer on an absolute value. I also want to remind you what the absolute value graph looks like, because we're going to focus on graphs. Since every x could have a positive or a negative, then that's why you're going to get the V shape when you graph an absolute value. All right, let's look at how to solve one. Okay, so number 9. We have absolute value of -2 minus 10W is equal to 98. So we want to, the absolute value is already isolated. There's nothing added to it, multiplied by it. So what we want to do is take the -2 minus 10W and say, well, that's either equal to 98 or -2 minus 10W equals -98. Okay, and then we're just going to solve these two equations as usual. So I would add 2 to each side, so I get -10W is equal to 100. Divide both sides by -10, and W is equal to -10. All right, when I go over here, I'm going to add 2 to each side. So now I have -10W is equal to -96. Divide both sides by -10, and W is equal to, that's going to be positive, and that fraction will reduce down to, I'll just put it in decimal form, 9.6. Okay, so now what you want to do is take -10 and plug it in here and check it, see if that makes a true statement. And then you also want to do 9.6 and see if that makes a true statement. I did check them and they both work, so we're going to write our answer as -10 and 9.6. Okay, here's problem 10 on your guided notes. So this time the absolute value is not isolated. I need to get rid of the -6. So we're going to add 6 to each side. So that's going to give me absolute value of 2b plus 4 is equal to 20. Now I'm ready to consider my two cases. So either this is 2b plus 4 is equal to 20, or this is 2b plus 4 is equal to -20. All right. Simplifying here, I'm going to subtract 4 from each side. So 2b is equal to 16. Divide both sides by 2, and b is equal to 8. Or subtract 4 from each side, and 2b is equal to -24. Divide both sides by 2, so b is -12. All right, my two possible answers are -12, +8. It's best to put your answers in order from least to greatest, so the negative is on the left. Now, if we plug both of these in for b and do the math, you will see that both of those work. Neither is extraneous. Okay, here's number 11. Once again, our absolute value is not isolated. It's multiplied by -4. So I'm going to divide both sides by -4. These two cancel out, so now I have absolute value of 7 minus a equals, negative over negative is positive, 36 over 4 is 9. So now I'm going to consider both cases. Either 7 minus a is equal to 9, or 7 minus a is equal to -9. Subtract 7 from each side. -a is equal to 2, and then to get rid of the negative, I'm going to multiply both sides by -1, so a is -2. Or if I subtract 7 from both sides here, I get -a is equal to -16. Still going to multiply both sides by -1, so I get a is equal to 16. If I plug both of these in, you're going to see we luck out again, and both of these are correct solutions. Now, don't get comfortable with not checking yours. I did check these, and we're going to look at one here in just a minute. I'm going to actually go through the checking process, and you will see that they don't always work. Most of the time they do, but you still need to check it real quick to make sure that it makes a true statement. Okay, so here's number 12 on your examples, and this time my absolute value has a 2 attached to it by multiplication and a 9 attached to it by subtraction, so I have to get rid of both of them. All right, let's get the 9 first. I usually like to get rid of numbers that are joined by addition, subtraction first. That creates less of a mess. So I'm going to add 9 to each side. This is going to give me negative 34 is equal to 2 absolute value 6 plus 8k. Then I need to get rid of the 2 that's been multiplied. So I'm going to divide both sides. Now I have negative 17 is equal to 6 plus 8k, which brings us to an interesting situation. The answer to this one is actually no solution. How do I know that already? Well, there is no way for a single absolute value to ever be equal to a negative number. When you take the absolute value of a number, it becomes positive or neutral. It has no sign actually, but you can never have a negative answer from an absolute value. So there's no way to get a solution here. Okay, let's move on. Okay, for number 13, we have 1 minus 10 times absolute value 9r plus 3 equals negative 29. So let's see what we can do here. First, I'm going to get rid of the number that's joined by addition, subtraction. Now, this number is actually positive, so to get rid of it, I'm going to subtract. All right, now here, those cancel out. So I have negative 10 times the absolute value 9r plus 3 equals negative 29 plus 1 is negative 30. Now let's get rid of the negative 10. We're going to divide both sides by negative 10. So now I have absolute value of 9r, and let me make sure that doesn't look like a 19. 9r plus 3 is equal to negative 30 divided by negative 10 is going to be positive 3. So now I have this isolated. I'm ready to consider both possibilities. This might be 9r plus 3 is equal to 3, or it might be 9r plus 3 equals negative 3. Let's solve this real quick. Subtract 3 from each side. So 9r is equal to 0. Divide by 9. R could be equal to 0, or if I come over here and subtract 3 from each side, I get 9r is equal to negative 6. I'm going to divide both sides by 9. So r is equal to negative 2/3. So my two answers here, I'm going to put the negative number first, or the smaller number first. Okay, and yes, once again, if you take these up here and plug both of them in, they will both give you a correct answer. Okay, let's look at number 14 now. Absolute value of 5a plus 8 is equal to 3a minus 10. Now this time, this is already isolated over here, but we have a binomial over here, and let me show you what to do. We're going to consider the first case just like it is. And then for our second case, we're going to say, well, 5a plus 8 could be equal to negative 3a minus 10. And then when we get ready to solve that, the first thing we're going to do is distribute that negative. So let's come over here first and let's go through our steps. There's nothing to simplify. I have a 5a and a 3a, so I'm going to subtract 3a from each side. So that's going to give me 2a plus 8 is equal to negative 10. And then I'm going to subtract 8 from each side. So I have 2a is equal to negative 18. Divide by 2. So a is equal to negative 9. All right, over here, when I distribute, 5a plus 8 is equal to negative 3a. It's going to make that plus 10. So I'm going to add 3a to each side. So that's going to give me 8a plus 8 is equal to 10. Subtract 8 from each side, and I get 8a is equal to 10 minus 8 is 2. Divide by 8. So a is equal to 1/4. Now, we are actually going to check these two, all right? I want you to see what happens. If I take negative 9 and I fill it in up here for a in both places, 5 times negative 9 is negative 45, and negative 45 plus 8 is negative 37. The absolute value of negative 37 is 37. Now over here, 3 times negative 9 is negative 27 minus 10 is negative 37. All right, 37 is not equal to negative 37, so this solution does not work. All right, now we're going to do the same thing with 1/4. I'm going to fill it in for A. Let me get all this. And we're going to multiply 5 times 1/4 gives me 5/4 plus 8. And then 8 is this, if I want to add fractions, normally I would just get a calculator out, but 8 over 4, to change it to something over 4 would be 32. So that's going to be 37/4 over here. And then if I put 1/4 over here, that's going to be 3/4 minus 10, which is negative 9 and 1/4. Well, what is this? This is, I don't even have to do the math because this is a positive number and this is a negative number. So for this one, both of these are extraneous, so it has no solution. Okay, number 15. Following our steps, the first thing we want to do is isolate our absolute value. So I'm going to add 5 to each side. So now you have absolute value 6n minus 7 equals, these two cancel out, 3n plus 5. And now that this is isolated, I'm going to consider both the positive and the negative. So either 6n minus 7 equals 3n plus 5, or 6n minus 7 equals negative 3n plus 5. So let's just solve. I'm going to move 3n over, or I'm going to get rid of this 3n. And I want to do the same thing to each side. So I've got 3n minus 7 equals 5. I'm going to add 7 to each side. So 3n is equal to 7, 8, 9, 10, 11, 12. Divide both sides by 3. So n is equal to 4. And if you plug 4 in and check it, it's going to work. Now let's come over here. I've got 6n minus 7 equals. When I distribute the minus, I'm going to have minus 3n minus 5. All right, now I'm going to eliminate one of my variable terms. Since this one is negative, I'll choose to add it to each side. So over here, I've got 9n minus 7 equals negative 5. Then I'm going to add 7 to each side. So I have 9n is equal to 2. Divide both sides by 9, and n is equal to 2/9. And I'm going to give you a break. I will tell you that I did fill both of them in, and I did work them out, and they do both work. So your answers here, let's put them in least to greatest, is going to be 2 over 9 and 4. One more problem. Okay, number 16, last problem. So we do need to isolate this. It has a 1/5 multiplied by it. So how do you get rid of 1/5? Well, you multiply it by 5. Anything you do to one side, you have to do to the other. All right, 5 times 1/5 is 1. So now I have the absolute value of 6x minus 1 equals, now when I distribute this, I'm going to get 5x plus 25. So now let's consider both cases. I've got 6x minus 1 is equal to 5x plus 25, and or 6x minus 1 could be equal to negative 5x plus 25. So let's just solve. I've got two variable terms, so I'm going to get rid of one of them. I'll choose the smaller one since both would have to be subtracted. 6x minus 5x is x minus 1. These cancel out, equals 25. Add 1 to each side, so x is 26. Or if I come over here, first let me distribute that negative sign, so that's going to be negative 5x minus 25. Now this time, if I got rid of 6x, I would subtract. If I get rid of 5x, I'm going to add. So I always choose to add when possible. So 6x plus 5x is 11x minus 1 is negative 25. Then I'm going to add 1 to each side. So now I have 11x is equal to negative 24. Divide both sides by 11. And x is equal to negative 24 over 11. And yes, I did check both answers by filling them in for x into the original equation. Both answers work, so I'm going to put the negative 24 over 11 here and 26. And that is the end of our lesson on linear, literal, and absolute value equations. Good job.